Hello everyone, this is lecture 7. In this lecture, we are discussing about the particular integral rules for linear differential equation of nth order. To find the value, this is the next case. To find the pi for this type of function when 1 over fd and the function of right side rx is the function of r is x to the power n sine ax or x to the power n cos ax. Before solving it, we have to just make few points clear that if a complex number 4 plus 5 iota, and we can write 5 5 is equal to imaginary part of 4 plus 5 iota. That means we are only focusing on the value 5. Now similarly, to write the 4, we can say that real part of 4 plus 5 iota. That means we are only focused about the real part of this complex term. So now for this, we can say that by the formula e to the power iota x is equal to cos x plus iota sin x. If we say e to the power 5x, e to the power 4x, then this will be cos 4x sin 4x. Now for this portion, like we have to write sin 10x. Sin 10x is equal to imaginary part of cos 10x plus iota sin 10x. That means we are only focusing about the imaginary part of this complete term, that is only sin 10x. We required only the imaginary part, sin 10x. So sin 10x is equal to this, and we can also say that sin 10x is equal to imaginary part of, because this formula is equal to e to the power iota 10x. So imaginary part of e to the power 10 iota x. So you have to remember this formula for solving this type of pi case. Similarly for the cos, suppose cos 7x is equal to real part of e to the power 7 iota x, that is real part of cos 7x plus iota sin 7x. Now after clearing these terms, we are going to discuss about the rule, that is for x sin x or x to the power n or x to the power n cos ax, we just convert the trigonometric term into the e to the power iota theta or complex form, into the complex form. Then we just write if x to the power n sin ax, then it is equal to the imaginary part of e to the power iota ax, and to solve this e to the power iota ax, we just replace d by d plus a. This is the rule which we already studied previously for the pi, that e to the power ax into function of x case. What we do, 1 over fd, we replace d by d plus a, and a is the value of exponential function. So similar term we are doing over here, iota ax is added in d plus iota a, and for the cos term we just write the real part of e to the power iota ax, and d is replaced by d plus iota a. Now we consider an example. This for CF, the auxiliary equation for the CF is m square minus 2m plus 1 is equal to 0. You just have to find out the root and calculate the CF. For the PI case, for the PI of this, 1 over d square minus 2d plus 1 and x sin x. And according to this formula, sin x is equal to imaginary part of this term, complete term. Now we are taking complete this term, the imaginary part of this is the solution. So by the formula, this value is converted into exponential function, that is e to the power iota x, imaginary part of, remember you have to write this imaginary part of term until unless you have not selected the imaginary part. So for this we just use the pi case, 1 over fd and e to the power ax into function of x. So e to the power ax will be first solved by converting d into, d is replaced by d plus iota, because over here we compare when e to the power ax and the value of a is iota. So we replace the imaginary part. So the imaginary part of this term, so e to the power iota x is solved. So we have put it on the left side of the term, and d is replaced by d plus iota, d plus iota. Now we simplify it, we get imaginary part of e to the power iota x and d square minus 2 1 minus iota d minus 2 iota x. So for the case of pi when x to the power n, now we have to again consider a different case, fd into function of x to the power n. For this case, this is the second pi case. For this case we have to expand binomially. So imaginary part of n denominator, in this term we are considering the lowest term, lowest coefficient of d, this, because this is 2 iota d to the power 0. We are taking minus 2 iota as a common. We get 1 minus 1 plus iota d minus 1 by 2 iota d square, and because we have considered it on the numerator, so the power is minus 1. Now by binomial expansion, the term which we required for binomial expansion is maximum dx, differentiation of x single time. If we use d square x, it will be 0, because the double differentiation of x is 0. So after binomial expansion, only the first and second term, first term will be 1 and second term will be this. So we get e to the power iota x, it converted into cos x plus iota sin x, and the remaining term is this after binomial expansion. Now x is multiplied to the inner part of the this left side term. We get imaginary part of 1 by 2 iota cos x sin x and x plus 1 plus iota. Now after multiplying the complete terms, after multiplying the complete terms of this bracket term, we are only having, we have to only consider the imaginary part. We just take the imaginary part, that is the solution. So the imaginary part is 1 by 2 x cos x plus 1 by 2 cos x minus 1 by 2 sin x. We have to remove, we have to forget the real part of. So this is the pi for the given question, only the imaginary part. Now we are considering the second example, that is d square minus y is equal to x sin 3x plus cos x. For this, the pi term is equal to 1 over d square minus 1 x sin 3x plus 1 over d square minus 1 cos x. This is the portion which we have already clear. We have already discussed the pi case. So this pi case you have to do yourself. I am only solving the part for pi1. This is, if we are saying this is pi1 and this is pi2, particular integral second. So pi1 is equal to 1 over d square minus 1 x sine 3x is equal to the imaginary part of imaginary part of 1 over d square minus 1 x e to the power 3 iota x, because as per the formula e to the power 3 iota x is equal to cos 3x plus iota sine 3x as per the formula. So this is the imaginary part of this. Now to solve this portion, what we required, imaginary part of e to the power 3 iota x, 1 over d is replaced by d plus 3 iota whole square minus 1 and x is same. Solving this part, we get imaginary part of e to the power 3 iota x, 1 over d square minus 9 plus 6 iota d minus 1 x. And the next step onwards, imaginary part of e to the power 3 iota x and 1 over d square plus 6 iota d minus 10 x. So now we have to solve it by using binomial expansion. So we are taking the lowest term, lowest coefficient value of d from denominator, that is minus 10. So imaginary part of e to the power 3 iota x over minus 10 and 1 over 1 minus d square plus 6 iota d over 10 and x. Now this is equal to imaginary part of e to the power 3 iota x over minus 10 into binomial expansion of 1 minus d square plus 6 iota d over 10 to the power minus 1 and x. Now expanding this term, we get imaginary part of e to the power 3 iota x over minus 10 into 1 plus d square plus 6 iota d over 10 into x. We are not required to expand more than dx, because when we multiply d square into x it will be 0 and this is equal to 1. So the imaginary part of e to the power 3 iota x over minus 10 into this x is multiplied to the bracket term, we get x, and this d square into x is 0, so we get only plus 6 iota over 10. Now again we replace the value of e to the power 3 iota x is equal to cos 3x plus iota sine 3x. So the imaginary part of the term e to the power 3 iota x over minus 10 into x plus 6 iota by 10 is equal to imaginary part of upon minus 10 cos 3x plus iota sine 3x into x plus 6 iota by 10. Now multiplying this term, minus 1 by 10 imaginary part of into x cos 3x plus x iota sin 3x plus 3 iota cos 3x by 5 minus 3 by 5 sin 3x. Now the outside value is written, that we have to only focus on the imaginary part. So the imaginary part are x sin 3x, 3 by 5 cos 3x, that will be minus 1 by 10 into x sin 3x plus 3 by 5 cos 3x. So this is the PI1. You have to calculate the PI2 for this question, and your final solution will be CF plus this PI1 plus PI2. Now you have to solve these two questions by yourself. That is, for this you have to use the rule which I have taught in this lecture. E to the power ax is solved previously, and this is also solved previously. The solution of this question is this. Similarly, for this portion you have to use the rule which is taught in this lecture. Thank you.